So, hello YouTube, everybody, behave, we're on YouTube, we'll be on YouTube. Day 16, I guess, so I need to make a folder and everything else. mkdir day 16. Wait, can I just type 16? Actually, can I type 6 and do this? Yeah. Touch main, touch input. Then I was doing a bunch of updates to Borg, my Twitch chat client. So let me close a bunch of these open stuff. Tweets, blog posts, element of code. Okay, let's refresh. 16. As you leave the cave and reach open waters, you receive a transmission from the elves back on the ship. The transmission was sent using the buoyancy interchange transmission system bits. A method of packing numeric expressions into a binary sequence. Your submarine's computer has saved the transmission in hexadecimal, your puzzle input. The first step of decoding the message is to convert the hexadecimal representation into binary. Each character of hexadecimal corresponds to 4 bits of binary data. Okay. The bit transmission contains a single packet at its outermost layer, which itself contains many other packets. The hexadecimal representation of this packet might encode a few extra 0 bits at the end. These are not part of the transmission and should be ignored. Okay. Every packet begins with a standard header. The first 3 bits encode the packet version, and the next 3 bits encode the packet type ID. These 2 values are numbers. All numbers encoded in the name packet are represented as binary with the most significant bit first. For example, a version encoded in the binary sequence 100 represents the number 4. Packets with type ID 4 represent a literal value. Literal value, oh my god, there's so many definitions. Oh, how long is this explanation? This is just part 1. Okay. So literal value. Literal packets encode a single binary number. To do this, the binary number is padded with leading zeros until its length is a multiple of 4 bits. And then it's broken into groups of 4 bits. Each group is prefixed by a 1 bit. I'm already lost. Like, my brain is not... I don't have enough space in my brain to remember all of these things. Okay, each group is prefixed. You complained yesterday that exercises weren't suited to low-level programming. It seems that you got served. Oh god, with a better fitting thing. Okay, each group is prefixed by a 1, except for the last group, which is prefixed by a 0 bit. Okay, so the first bit tells you if it's like continue or not, I guess. These groups of 5 bits immediately follow the packet header. For example, the hexadecimal string D2FE28 becomes this. Below each bit is a label indicating its purpose. So the 3 bits labeled V are the version 6. The 3 bits labeled T are the tab ID, which means the packet is a literal value. The 5 bits labeled A start with a 1, not in the last group. Keep reading. And contain the first 4 bits of the number 0111. The 5 bits labeled B do the same and contain, I guess, the more bits for the number. The 5 bits labeled C start with a 0, so it's the last group, end of packet, and contain the last 4 bits of the number 0101. The 3 unlabeled 0 bytes at the end are extra due to the hexadecimal representation and should be ignored. So this packet represents a literal value with binary representation, blah blah blah, which is 2021 in decimal. Okay. Every other type of packet, any packet with type ID other than 4, represents an operator that performs some calculation on one or more sub-packets contained within. Right now, the specific operations aren't important. Focus on parsing the hierarchy of sub-packets. An operator packet contains one or more packets. And we are halfway through. Oh my god, I don't have enough brain juice to do this. To indicate which subsequent binary data represents its sub-packets, an operator packet can use one of two modes indicated by the bit immediately after the packet header, which is called the length type ID. By the bit immediately after the packet header. Okay, so... Okay. So if the length type ID is 0, then the next 15 bits are a number that represents the total length in bits of the sub-packets contained by this packet. If the length type ID is 1, then the next 11 bits are a number that represents the number of sub-packets immediately contained by this packet. Finally, after the length type ID bit and the 15 or 11 bit field, the sub-packets appear. For example, here's an operator packet, hexadecimal string, blah blah. So, packet version 1, packet type ID 6, which means the packet is an operator. The bit labeled I is the length type ID, which indicates that the length is a 15-bit number representing the number of bits in the sub-packets. The 15 bits labeled L contain the length of the sub-packets in bits, so 27. The 11 bits labeled A contain the first sub-packet, a literal value representing the number 10. The 16 bits labeled B contain the second sub-packet, a literal value representing number 20. I'm missing one thing. How do you know where one packet ends and the next one begins? After reading 11 and 16 bytes of sub-packet data, the total length indicated L27 is reached, and so parsing for this packet stops. I'm guessing you know because the packet structure is known, but it's the leading zeros. How do I know? Oh, I guess because I need to do... I get to here, and then if I modulo 4, I'm good. Otherwise, if like there's, in case, I guess in this case there were 3 bits remaining to be modulo 4, so that's why I know that this needs to be ignored and they're not going to be another packet. Okay. So 16 bits contain B, blah blah blah. So after reading 11 blah blah is reached, so parsing this packet stops. As another example, here's one with length type ID 1. It contains 3 sub-packets. So we I is a length type ID, which indicates that the length is a 11-bit number representing the number of sub-packets. The 11 bits labeled A say there are 3 packets. So we start parsing one packet, then we parse another packet, then we parse another packet. After reading 3 complete sub-packets, the number of sub-packets indicated L3 is reached, and so parsing of this packet stops. For now, parse the hierarchy of the packets throughout the transmission and add up all the version numbers. Here are a few more examples of hexadecimal encoded transmissions. Blah 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 blah. Decode the structure of your hexadecimal encoded bits transmission. What do you get if you add up the version numbers in all packets? Okay. Okay, let's get to parsing. So let's see what people are saying. Just do it step by step. I found this part of the description super confusing. The puzzle is deciphering the description. There's like, I mean, I'll have to be honest. My brain was kind of tired and was telling me, no, I don't want to do this shit. Go do something else, please. But as I started going down, I'm starting to grok it a little bit, and it's not that bad. This is nothing compared to the garbage you find out there. Like, let me show you my favorite one. I was paid to do this stuff at one point. ISO 8583. ISO 8583. And this is this. So if you want this pack, you have to pay for it. It's insane. So these are like packets describing like credit card transactions, and they do this shit that you saw here, but even worse. What they do is that they have stuff like, for example, some numbers are ASCII. So like if you want to have a number that says 20, it contains 2 bytes. One byte is the character 2, the other byte is the character 0 in ASCII, and then you have to parse int. And some other fields instead are binary, big endian. Some others are what they call ABC encoding. BCD encoding, I think. BCD encoding. BCD encoding, binary encoded decimal, it's kind of like ASCII, but it uses fewer bits. So it's like it can only encode numbers. So basically you look at stuff 4 bits at a time. It's so stupid. And you had all these encodings in a ISO 8583 packet. Like they would all be in there. It's insane. So like this shit, so this compared to this is nothing. I'm gonna fuck it up anyway. You can be certain of it. But the reality is oftentimes much worse. Okay. I found STD format hex to bytes and STD IO bit reader helpful. Thank you. Nice. I'll check them out. Hex to bytes and bit reader. Actually, let's go do it now. Maybe there's also a nice data structure inside standard library that could be useful. Let's take a look at zig.zig. No, actually it's not zig.zig. I care about std.zig right now. So std.zig is like the entry point, and it exports every single symbol that you can access by doing std.something. I usually don't look at this file because I kind of know what's in here and I already know where to go. Like if I want to go inside mem, I know that I have to go inside mem.zig. But it's useful for data structures, right? Look at this. Priority queue. That's our friend from yesterday. Packed int slice endian. Packed int slice. Packed int array. Maybe packed int array is useful? I have no idea. Let's look at the letter B. Bit. Bounded array. Buff map. Buff set. Let's take a look at what's packed int array out of curiosity. Packed int array provides a set of functions for reading and writing packed integers from a slice of bytes. So, okay, you know what? Let me look at the... So, if you want to know how something should be used and you have no idea how to use it, a good way of doing that is looking at the tests. Like, you look at the tests, and you can take a look. So, this says... I'm guessing these are 8 U3s. And then, okay, let's see, maybe there's better usage. So this is the endian version. Is there a simpler version? Packed int array, okay. Let's see. Packed int array. Type A, oh, this is very generalized. Packed int IO. Little get. Packed int array, U3, 8 of those. Packed array, so creates 1 from an array, and these are the numbers. And then expects equal. I'm not sure this is going to be useful. Maybe I'm wrong. Okay, let's look at these. Hex to bytes. FNT hex to bytes. I mean, I think I understand what hex to bytes does, but just to... Because the sequence of bytes represented by the specified string of hexadecimal numbers returns a slice of the output output buffer containing the code bytes. So this is nice. Okay, this is our entry point, right, for parsing. And then std io bit reader. Are there parser combinators in Zig? Yes, there's one. Mecha. The nice thing about Zig Mecha is that it's a parser combinator at comp time. So it's doing the combining at comp time, and basically it produces, like, there's no runtime overhead to combining parsers. I mean, like, it's not done through like dynamic stuff. It's cute. So check it out. I'll share the link in chat. So IO bit reader. I'm not sure about what IO bit reader should be used for though. Bit reader engine creates a stream which allows for reading bit fields from another stream. Read bits on your app, read bits. Reads bits from the stream and returns a specified unsigned int type containing them in the least significant end. You know what? Okay, I know that it exists. I'll start working on the solution and then we'll see if I happen to find a way of using it or not. Worst case, you can scream at me. Okay, so we need to start parsing this shit. So first of all, we need to go from hexadecimal stuff to bits. Oh, I think I understand. So like you do, okay, I think I now understand. So you do hex to bytes to get a slice of bytes. And then you pass this slice of bytes to the bit reader so that you can read a few bits at a time from the bit reader. And like you consume a bit stream from the bit reader. It clicked. Okay. So Sublime, day 16. Let's steal some stuff before we open the new file. Maybe this, or well, I'll copy more, but some of this stuff has to go. I don't care about this. Okay. So let's copy some simple input, I guess. Well, let's start with this. Guess who failed at copying? So we can just straight up call hex to bytes and we get a slice of bytes. So nice. So should be just, it just gives us straight up a slice, right? Oh, I don't have it open anymore, but yeah, I think so. Const bytes is gonna be st.fmt hex to bytes. No tokenized today, so sad. Input. I think it required more arguments though. FNT. Out and input. Huh. That's interesting. Returns a slice of the output buffer containing the decoded bytes. So, is there like a hex to bytes alloc or something? No. So we need our out buffer to be big enough. Oh, but we can know how big it is, right? It's just half of it. Like, right? Yeah, just half of it. So that's easy. Okay, so var So I guess we can do var bytes and we can just ignore whatever this returns because we know exactly how much we're going to consume, right? So var bytes is going to be an array of u8 long input dot len divided by 2, but this needs to be an integer stuff, so add div exact undefined bytes input. So this should work. You know what? We can do it like this. If this calling this dot len is different than bytes dot len, then we complain. Let's see if it panics. Unused local variable. Okay, that's fair. We'll take a look at the allocator later. Error, exact division has a reminder. God damn it. Why does it have a reminder? So am I missing something? Oh, I know what I'm missing. Is there like a stupid new line? No, there is no new line. But I mean, that's fair. Yeah, that's 21 characters. So wait. I think I'm missing something. I pasted labels. Thank you. I'm a complete moron. Thank you. Oh my god. Yes, thank you. Oh man, my brain. Okay, expected type U8 found an array. That's fair. We need to pass to this function bytes by pointer. No, that was correct. Because we are modifying that array. Type info blah 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 error union. Okay, so it's a try. That's fair. Parsing could fail. Oh, and we need to do len after we do the try. Okay, it works. Nice. Okay, so we have our bytes now. From our bytes, then we should use the bit reader so that we can get a stream of bits, which is also nice. And then we can consume them as we do our parsing. Okay. So how do we use the stdio bit reader? Let's go find out. Bit reader. So bit reader. So this is the uppercase bit reader function. Usually for this reader writer stuff in Zig, these are just type definitions, and they want a lot of stuff. Sometimes there's like a lowercase version of it. What do you know? That does stuff for you, which is nice. So you call the lowercase version, and it gives you a instance of a reasonably well-defined configuration of the type. And so we give it an endian thing and an underlying stream. But I think that the underlying stream... Can the underlying stream really just be a slice? According to this test, it seems that's definitely the case. Where like the underlying stream... So this is any type. So underlying stream here doesn't really specify the type. But then you have to be sure that this thing supports slices, which is not necessarily the case. I had no idea this was the sleep. Yeah, that's awesome. So okay, so BitReader it's a very nice helper. And so by the way, it's not just BitReader. All the other readers have tiny helpers like this that help a lot. So I think you need to make an intermediate. I don't think so. Look at this. Oh no, wait, you're right. This is a fixed buffer string. God damn it. So yes, the intermediate is I somehow failed to read this correctly and assume that this was, I don't know why the bit reader, that doesn't even remotely look like the bit reader. So yes, so you take it a slice, you pass it into a fixed buffer reader, and then you pass the fixed buffer reader to the bit reader, and you give it the right NDNS, which in our case is big. Is it? I don't remember. Yeah, it's big. I don't remember. We'll find out. Fixed buffer stream. Oh, you know what? FBS. We don't really care about it. It's just an intermediate. So FBS is going to be also needs to be modifiable. std.io.fixBuffReader. We pass it bytes. Then, so the test is helping us understand how to use it, right? So we do io fixed buffer stream. Okay, so these are full names: fixed buffer, and it's not reader, it's a stream. Okay, so fixed buffer stream, and then we call it bit reader on the reader interface of this stream. Yes. So var, I don't know, bits, yeah, std.io.bit reader over I don't know, is this big or little? Oh, whatever, dot big, we'll find out. fbs.reader. Okay, and then now bits will have a reader interface. So bits is this implementation here, which has read bits no EOF, which has read bits. Oh wait, is this already a reader? This doesn't have a reader interface, does it? It's already a reader. It's a weird reader. No, okay, it's a weird reader, but it also has a standard reader interface. So we can either use these like specific methods for reading bits, which I think that's what we want, but we also use it to read stuff normally, like you read all the normal methods that reader interface is exposed. I think they call it a bit reader is a weird name when there's also a reader interface. There should be, I don't know, maybe another name. I don't know. Okay, so we start reading bits. I guess that's it. So reading bits, self. Okay, reads bits from the streams and return a specified integer unsigned type containing the least significant, containing them in the least significant end. The number of bits successfully read is placed in out bits. As reaching the end of the stream is not an error. This interface is a little bit weird. Okay, so let's go back to what it is that we need to, so you know what, I think I'll copy this signature just for convenience. So I'll paste it here, and then I'll use it to inspire me completing it. So let's try to parse this thing. So we need to read 3 bytes, right? Sorry, 3 bits to get the packet version. So that's the first thing we do. And then we need to read 3 more bits to read the packet ID. So that's the first thing that we do, right? So I guess I need to make a like throwaway variable like consumed, and define like, I think I don't care about consume, ideally, hopefully. So I need to do then const version is bits dot read bits AU3. We want to read 3 bits. Fill it entirely with 3 bits. Maybe this is a cheat code, like when you can read less bits than the container that you want to pass around. But whatever. And out bit is going to be a pointer to consumed, I guess. And that returns an error and a version. So this is it. std.debug.print result. I think consumed is gonna be, no, okay, consumed is used, so Zig is not going to complain. Why do I have the release fast thing here? No release fast. Result 6. What do you know? Type. ID. Six and 4. Okay. Then we have different type IDs, right? And based on the type ID, we have to decide what to do. So based on the type ID, if the type ID is 4, we know the packet is a literal value. If the every other type of packet, any packet with an ID other than 4, represents an operator that performs some calculation on one or more subpackets contained within. Right now, the specific operations aren't important. Focus on parsing the hierarchy of subpackets. So basically, we need to have something that says if type ID is different than 4, then we need to go into the other thing. So I think we need a function and do some healthy recursion. Parse packet, I guess. Bits is going to be a pointer to a std.io.bit reader. Do I need to pass a pointer to it? I think yes, right? Because I'm applying side effects to its contents. Am I? I'm not sure. Can I pass it around? Forward, reader type. Maybe I don't. I think maybe I do. I think I do. I think I need to pass a pointer. You never freaking know. Let's do it. Thank you for the follow, Identity GS. Welcome to the stream. That's what people are saying. Intermediate. I started doing a Z solution and read specific bits by hand. I gotta stop and tune in. Nice. Thank you, Two Step. That was a great recommendation. So we give it a pointer to the reader. And then what else? Well, no, I think we need to have specific functions. Do we? Maybe also yes, but there is a common part. Like, I think this is the same for everybody. So let's do this. Then what else? So we read from bits, and then we switch over parser or over type ID. If it's 4, we do something else, we do something else. So let's do the for case, which is easy. So if it's the for case, also we don't know what we are returning. I think we need to return a packet definition. And a packet. Oh, I know what we are returning. We're not returning a packet. We're returning a... let's do a pointer to a packet. Hell yeah. Const what? A packet is gonna be a... How should we do it? Well, it should be extract, I think. So we have version, usize or whatever. Actually, it's a u3, right? Type underscore ID is a u3. Well, okay. Then let's do extra. And it's a union. Doesn't even need to be tagged. Like I'm basically duplicating the tag outside and inside. You know what? That's the tag is in the enum, I guess. So the enum is going to be, what are our cases? We said literal was one case, and when it's a literal, it's just a number, I think, usize or whatever. And we don't know any of the other cases, I think. We know there's also control, but I don't remember what. Oh yeah, I think it was control. Control contains. Control contains a slice of packets. So actually, we don't need to return a pointer to a packet. I think we can return just a packet. I think that's how it is. The first approximation. Okay, so here we have version, here we have type ID. Then we will switch on the type. And at this point, we know that we can return a packet with version equals version, type ID equals type ID. And extra is going to be I always forget how to do unions literal stuff in Z. Extra is going to be is it like this? I think it's like this. Yeah. Literal equals what? Is try parse literal bits, I think. think. I forget what the actual type of the number is, but we're gonna find out, aren't we? There's a literal value. The literal value packets encode a single binary number. To do this, the binary number is padded with leading zeros until the length of multiple bits, and then it's broken into groups of 4 bits. Right. Blah 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 blah. 0 bit, the groups of 5 bits immediately follow another packet header. Follow the packet header, for example, the hexadecimal string, blah blah blah. So we did this. And then we have these five stupid bits at a time. So I think we do it the safe way, and like we... I guess we keep shifting it, like we put... So we make a use size 0. We put in 4 bits. We find that if it's a 1, we also shift left by 4. And we keep doing this until we find a 1, until we find a 0, where we add the bits, but we don't shift anything. And we hope that a use size is big enough for these stupid numbers, I guess. Okay, so parse literal, that's going to be pretty annoying. So var result is a use size, it's a SUSY, set to 0. Then we read 1 bit from our bit reader, or actually I think it's kind of like this. While we keep reading 1 bit. Also consumed, I think we can make it like a global. We really don't give a shit about this consumed. I think this is like a problematic part of the API or something, I don't know. So we read 1 bit, and while this bit is 1, we read 4. We shift and read 4. Shift and read 4. I think we can do better. I don't know, whatever. Let's start doing it. So we find a 1, then we read 4, var. Or actually, we don't even need an intermediate, I think. So shift result. So result. Do we have this? I think we do, right? Shift equal. Do we? I don't know. So operators. 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 Shift equal, shift equal, shift equal. What do you know? Shift equal. So we shift equal left by 4. And then we do result is or equals with try bits dot read bits what a u4 4 bits from put everything consumed. So we shift, put them there, And we keep doing it until or you know what, this is a case where knowing how many bits we have consumed is actually useful, so never mind. Var c usize equals 0. So you what, maybe consume didn't need to be global. Oh, okay. So here we keep track of consumed, but we start at 0 because we actually do care about the initial value. So we count how many bits we have consumed. We read a bit is actually 0, so we don't shift, but we do this. Also, here's the problem. Consumed is like, oh shit. Okay, this should be like C. And every time we do this, so we also need consumed. And every time we loop, we add 5. Because that's 1, that's gonna be 4. Let's say that we do it 0 time, this doesn't happen. We do it 1 time, 5. We do it 2 times, 10. That's fair. We consume 1 more, then we do this. Then we need to do consumed plus equals 5. Okay, so now result contains the freaking number, finally. And we need to know if we need to read any 0 that remains. Well, read any extra 0. So we do this by doing consume modulo. No, we need the reminder. So yeah, so we do const remain rem is going to be consume modulo 4. And if rem is greater than 0, we throw away. Well, actually we don't throw away. You know what we do? If rem is greater than 0, if reading usize what rem is different than 0, not undefined but unreachable, so we panic. So let's see. I'm almost sure you need to leave the training zeros. They can be part of the next packet. Are you sure? That might be the case, but it seemed to me. So it seemed to me here that these zeros. Oh, you think it's that the case? I thought okay, that's a good point. I don't know for sure. That's how I interpreted the description. But you know what? I have a neat unreachable that also makes sure that they all are zeros. So I don't know. Let's see what happens. Worst case, I disable this, right? We'll see. This is to be checked. I don't know. That's how I read this, though. The tree labeled 0 bits at the end are extra due to the hexadecimal representation and should be ignored. So basically, these hexadecimal representations, has pushed these bits into our thing. So even though these bits don't have any meaning for our packet, I think they should be consumed if they should be consumed if they're there. I don't know, we'll see. Okay, so I think we parsed correctly the literal value, right? So if this succeeds, return a value, and parse literal succeeds, and parse packet returns a packet. So let's do blah blah blah. Let's do the packet p. So we do var const p equals parse packet bits. Also, there's a bunch of tries in there, so this needs to return an error union. I think there's tries in here too, so this also returns an error union. Okay, we should be good. Let's see. Okay, let's fix the other type. Expected type found function indent type any type. What? That's an uppercase B. Oops. Okay. Expected type found again. Oh shit, right, that's a function too. So what's the type of this bit reader? The type of this bit reader is bit reader. That's the annoying part. That's the annoying part, because that bit reader is generic with regards to the reader that it also wraps. So this is our type. It's an uppercase bit reader, big endian. You know what? It's definitely time to make this a type somewhere. So I const bit my bit reader is bit reader dot big, and then fixed buffer stream, I think. Let's see if this is gonna be enough to satisfy it. I just use any type. Yeah, I know. I actually, you know what? I should be using any type. Why am I stressing over this stuff so much? Use an identifier fixed buffer stream. Good point. That's in the standard library. Expected type found function type any type. God damn it, that's a type. What are the what? Oh my god. Okay, let's now I'm getting angry. Let's go find out. Yeah, I should be using any type. I don't know why I'm doing this. Where's the fixed buffer? God damn it. Also, did I do fixed buffer stream correctly? Yes, fixed buffer stream. Oh, it's a buffer. So what do you get? 496, I guess. It gives a fixed buffer stream non-sentinel span type of buffer. Non-sentinel span. It removes the sentinel, but no, I think this is different. I think this is a slice. Like the type that you pass to fixed buffer stream is not just it's a slice. Maybe I'm wrong. Let's see. Holy shit. Expected type, at least the expected type is gonna tell us what the fuck this thing is expecting. So expected type, std, io, bit reader, std, big endian, std, io, fixed buffer stream, consummate found. Okay, we're close. Found bit reader, std, big endian, yes. std, io, reader. Oh, that's the actual type. Because it's a reader, right? Because we're not passing the fixed buffer stream immediately. We're passing a reader. Oh, but wait. Because I can do this dot reader, I think. I think this is gonna expose its reader type. So expected blah blah. We are getting close. So bit reader blah blah blah. Comma SDO reader fixed buffer stream U8. I said const. The thing that didn't say const. Is this it? Yes. Type. Return type. Optional error union. Error set packet does not support initialization syntax. What? Error union. Error set packet does not support initialization syntax. Referenced here. So I'm close, but not quite there. Line 26. What happened in line 26 that's so wrong? Try parse packet. Packet. Oh, I know what's happening. I think this is not always returning a packet, right? Else do nothing and then return error dot unsupported packet or something. So I think this is a starting point. Oh, you're right, and then this needs to be explicitly packet. Non-member type ID instruct packet. You sure about that? Oh yes. Because I mean, I could leave it there. It's wasteful, but whatever. Let's leave it there. It's useful probably for the purposes of the exercise. Integer value 1 cannot be coerced to type read error. Yes. Okay. So I need more parentheses around this try. So I guess that this try also suffers from the same finding precedence problem. Extended type usize found void. Parse literal. Good point. Where is this? When is this thing returning? This thing needs to return result. What do you know? Literal 127. Is that it? Were we ever told what the value was? Oh, yes, we were told, and it's a different one. What? Why am I getting 127 instead of 2021? Is there a way to let if you are the type for abstract? Yes, the dot syntax is for this. The problem in this case is that here the return value is an error union and it's not just the type. But I think this is a limitation of the current implementation. I would fully expect the full stage 2 parser to actually do this correctly. So you just say dot and it understands that you're not trying to make an error, but you're actually trying to make an instance of the packet. So if I didn't have this question, the exclamation mark, like if nothing tried could return errors, I would be able to do this and it would work. But again, I think it's a limitation that can be solved at one point. Okay, so why my number doesn't match? What's happening? I think we're not reading garbage. So up until now we're reading good stuff. It's here that something is happening. Let me see. Result is 0, consumed is 0. We read into C. We actually don't care about C in this case. So like we're reading, but we don't care because we are keeping track manually. Like we are also assuming that the stream doesn't end. And we are not checking for that, unfortunately, but okay. So I keep reading. "127 is prefix of 2021, I think. Well, it's correct, no? I read 1 bit, and then I read 4. I read 1 bit, and then I read 4. And then when this is a 0, I still need to read 4. Oh, you know what's happening? I still need to do like 1 shift again. Like I also need to do this anyway. I thought I didn't need to shift, but I actually do need to shift. Also outside. What do you know? 2021. Okay. Next. Everybody knows, blah blah blah. So that's an operator packet. The operator packet contains 1 or more packets. To indicate which subsequent binary data represents its subpackets, the operator packet can use one of 2 modes indicated by the bit immediately after the packet header. This is called the length type ID. Okay, so the length type ID is a single bit afterwards. So we need a function for parsing this stuff. So function. You know what? I'll leave parse literal below since we don't want to look at it anymore. Parse operator. It's a pointer to my bit reader. Usize. No, actually. So parsing, we are parsing the operator body, right? So we are returning a slice of packets. Let's go. Okay, parse operator. I think we can see that parse operator needs something else. So we're returning a pointer of packets. Where do we grab the memory for this? And I think the answer is we're allocating this time. So I could, I guess, right now we only care about. I could make a function that like doesn't keep in memory the packets and we just aggregate stuff as we parse, but whatever, let's do proper parsing with the proper packet sheet, and it's wasteful, but that's how I'm rolling today. So we need an allocator, which is going to be a sd.lem.allocator. And what do you know? I just so happen to have an allocator here, which I'm going to pass to parse packets, to parse packet. Do I need a different function in this case? Should I have this do the operator work? No, because I think I need to recurse into this. Yeah, I'll need to recurse into this. So let's add the allocator. One packet B has a leading 0, so consuming 0 after the packet destroys that. Packet B has a leading 0. Where do you see packet B? Are you referring to this? Well, but the fact that it has, I'm not consuming zeros randomly. I'm only consuming zeros to realign myself to the hexadecimal. I'm guessing that so many people are complaining about this that probably is not correct. But it's like I'm not consuming every random 0 that I find. I'm just consuming the ones that would put me, that would ensure I consume an entire hexadecimal thing. Although maybe they say this in the encoding somewhere and I forgot. Maybe actually they do this. So let's see. this represents an operator packet version 3, which contains 2 subpackets. Each subpacket is an operator packet that contains 2 literal values. This packet has version of 12. We can pass in these tests and see if it works. So it's like try it, doesn't work, comment the 2 lines, it's gonna work ideally. Okay, parse operator, passing an allocator, and we pass the allocator down to the other case. So return packet dot version equals version. Oh, you know what? You can see it, right? I can see it. It's time. We're doing it. We're doing it. Ah, you can stop me. You can stop me. You can't stop me. Oh my god, my parentheses are going everywhere. Extra, we switch over 4, returns this, comma, no semicolon, else. There's gonna be another thingy. Comma, packet ends. No, switch ends, packet ends. No, let's see. Expected closing parentheses, pound comma, 48. Oh, there's an extra comma. There we go. I need a comma in here. Nice. So we do a packet. This is in common, and then the extra depends on the switch case. So in the else branch is gonna be a operator, and we try parse operator. We pass down the allocator, which parse operator will need. In parse operator, we start parsing freaking packets. Okay, so we need to read 1 bit to see which case we are in, right? So we need our own local consumed. Then this is gonna be length. What was it? What did they call it? Length type. Length type ID. Okay. Length type ID, LTI. So we read the LTI, and then based on the LTI, what is it? If it's 0, then it's bits. If it's 1, oh sorry, no. If it's 0, then I read 15 bits to know the total length in bits. If it's 1, I read the subsequent 11 bits to find the number of subpackets. Okay. Also, what do I do with this information? Shouldn't everything already check out naturally? I guess I can check. I can double check with consumed somehow. Worst case, I can wire in some bit count stuff everywhere, but okay, switch LTI. Also, this is 1 bit. I wonder if I could put bool in here. Maybe I can make this count. So here's the idea. Okay, I do get the count. What do I do after I got the count? I actually need to parse the freaking packets. Okay, I get it. I need to parse the freaking packets inside the while loop. So it has to be like, but it depends also on the case. So you know what? I think I like the switch and I'll keep the logic inside. I think it's different enough. So this is the 0 is the bits case, is it? Yes. So we need to read 15 bits. Okay, so bit count 15 bits. 15 bits. And then the switch is not an expression anymore. So we read 15 bits, and then we say basically while var I equals view size equals 0, while I is lower than bit count, we keep reading and we increase I plus equals bits consumed, something like this. While down below we have kind of the same situation, except that we have packet count and it's 11 bits. I don't know why I'm also changing the type, it doesn't really matter. So while I is lower than packet count, we just increase it. So for packet count is easy, right? Because we don't need to keep track of anything. It's like every time we do an iteration, we got a packet and we're good. Although in this case, here's what we can do. We know how many packets are there. We can do this. We can do var result equals allocator dot what is it? Create, destroy, alloc. I think it's alloc, right? When you want to do when you want to make a slice. So I want to make a slice of packets. Long packet count. And then every single time we do result index I equals try something, then we return a result. Well, in this case, this is a bit more complicated because we need to do this, and here I think we need an array list. So var result is std.array list, an array list of packets, init it with the allocator, and then every single time, we do this, but ours is gonna be result not append. I don't know why I'm doing this. In reality, like we could do the same also, the array listing down here. Doesn't matter, but for some reason I'm trying to program it reasonably well, even though it's advent of code. In any case, so we append what? A call to something that we don't know yet. And then at the end we return a result. So here's the thing though. We do this. Actually, yes, we do it while it's below, but then when it's not below, we need to answer that the bit count is the same. So if I is different than bit count, unreachable. I want a nice crash at that point. That's it. Now, what are we calling? We are definitely calling parse packet. Passing the bits, passing the allocator. And unfortunately, we want to do the same here too. The problem is, how do we keep count of the freaking bits? And this is when... So we have a counting reader, I think. Where is it? What's my counting reader? What do you know? We actually do have a counting reader here. A reader that counts how many bytes has been read from it, though. So the problem is that the counting reader, so we could wrap a reader around the counting reader, but the problem is that the name is so confusing. But the bits reader that we are using, we are not using it through the standardized reader interface. We are using its custom methods. So if we do read bits, like read bits, it's not a standard reader method. The standard reader methods are the ones defining a reader. So that it's like read all, read no EOF, read all array list, read all alloc, read until the limiter array list, blah blah blah. So these are the normal reader interface methods. So we can't wrap in our counting thing. God damn it. So you need bit count, not byte count, right? Right. So I guess we need to maybe we just need to say, so how do we wire this stupid thing? We could add this property to our definition of a packet. We say also how many bits it was. Or we can have a global variable somewhere and keep incrementing it and resetting it at the appropriate time. Let's do the less bad thing, I don't know, like the least error prone thing, which is, let's add it here. Okay, so now you make a packet, you also need to count how many bits you've consumed. Shit, that's gonna completely fuck up my thing here. You know what? Never mind. Global it is. Let's go. Nobody uses global anymore. Oh man. Watch me. Okay. So the global is going to be, I don't know, bit count var bit count usize 0. All I think it's adjusting it because it's shadowing something. Total bits. So it starts at 0. Well, it doesn't matter what it starts at. We can actually start it at undefined, but we care about resetting it here. Total bits. Well, not here. Oh shit! What if an operator contains an operator? God fucking damn it! We can't have just a global thing. Ugh. We're going back from the global to the older design. Never mind. I can't have a global because it's nested. Because you can have an operator inside an operator, so you can't just reset it. Oh, so annoying. Okay, so this beautiful thing here can't be done anymore, because now when I call try parse literal, I need to, like, the result is gonna has to be more complicated than this. Because we need to know how many bits were consumed there. Alternatively, you know what's the alternative? There's a third option. So, open your mind. It doesn't have to be global or embedded in your return value. There's a middle ground where something is neither global, neither a return value, but it's a little bit of both, which is what the original Bitstream API is already doing, the thing that we all hated, which is, what's it called, like an out parameter. And I think that's what we're gonna do. So Here's how it's gonna work. Let's start with parse literal. Parse literal accepts a pointer to a usize. And in here, we're using consumed to keep track of everything, right? Before returning, here's what we do. We do total count dot star equals consumed. So we set it into this variable. Now, who invokes parse literal has to pass this stuff. So let's reuse this consumed here. So once we get here, we do consumed equals 0. So we reset consumed. Actually, yeah, we do reset consumed, or rather, we should set it to 6 because we have consumed 6. Oh, it doesn't matter. We set it to 0. Then we do const p equals packet. We pass a pointer to consumed. This is so disgusting. Could you return a tuple instead? I could. Or rather, yes and no. Returning multiple values from Zig is annoying. I could specify like a type on the fly that also bundles this stuff, but it's like, it's ugly. Maybe it's not as cursed as what I'm doing right now, but it's still stupid and ugly. And would require me to rewrite more stuff. Like this out value, this out parameter thing allows me to keep this expression that I like and I don't want to drop. We have the packet. Consume equals 0. God damn it. We need to... Okay, so here's how it works. Never mind. We can set this to 6. But what we do, no, you don't set it, but we increment it with consumed. So we leave whatever was in there already. So consumed equals 6 because that's how much we consumed. This increments it. This increments it. And now consumed has the final count. And now we have total count pointer to usize. And here we do the same. Total count dot star equals plus equals consumed. There we go. So this is all bubbling up. Parse literal bubbles it up. Parse packet bubbles it up. Parse operator now needs to bubble it up. My solution was to wrap bit reader adding a position field. That's actually not a bad solution. Yeah, that's so much nicer. Whatever. I'm going for the cursed solution. Let's see this path to the end. So, okay, am I tossing away bits? Am I losing bits around? You know what? Your solution is so much better because with this I'm like leaving bits left and right. Although here I'm counting well, so it's like it's not really completely lost. Here I'm also not doing anything crazy. It's like I'm reading 6 and then I just need to aggregate whatever was there and then pass it up. So parse operator I guess is the most complicated thing for now. You could read length bits from the input and only pass them to parse packet. You could read length bits from the input and only pass them to parse packet. I'm not sure I'm following. Keep in mind that these are all recursive and called each other. Still don't get where you read that you should throw away zeros. I'm not throwing away zeros. I'm throwing away if what I consumed doesn't... I don't know. It's this part here. It's this. It's this part here. That's only at the end of message. Oh. Well, I see. Okay. We'll see. Ah, pork ban. Wait, did I get it wrong? How many T's is there? Ban? T T T T T T T T 1. Okay. So I have my curse consume stuff. Here's one. This is horrible. Yeah, I'm really thinking that I should wrap my bit reader. Okay. So I read 1, I read 15. I read 1, I read 15. So I guess I can do this. You do total count dot star plus equals plus equals 1. Then I do plus equals 15. I do it at the moment. I'm updated upstream immediately. Here I'm gonna be reading something, consuming something. So I guess I need to make a variable. Man, this is so horrible. You know what? I really think I'm gonna undo everything and just do the wrapping thing. Oh no, stage 2 meeting is happening. Well, I'm stuck here. Yeah, I'm wrapping my bit reader. This is so terrible. I expected it to be bad, but not this level of bad. Especially when we really don't need to do this. If we can wrap the other thing, that's so much better. Let's walk back from this decision. I got so close. It's just that the middle implementation is so bad, and as I'm going to complicate it later, potentially, it's gonna turn even worse. So I don't want to stay here forever. So consume goes away. This goes away. Consume here is fine. Total count is fine. Wait, I think I removed and consumed from some legit calls. Let me undo some stuff. Yeah, that was fine. That was fine. That was not fine. It's total count that needs to go away. So this needs to go away. This needs to go away. This needs to go away, and this needs to go away. Okay. Okay, so my bit reader now is something more complicated. I guess it's a struct. Bit reader, that's this, and count use size. That's my bit reader. And to make my bit reader, and you know what? We can add to it, so that we don't have to change this method calls, we can add to it a read bits method. So pub function read bits method comp time t type bits use size, I don't know, Oh, and then there is a... I was having the Clash API too! Holy shit! Holy shit! Var... whatever. Also we need south. Holy shit, that's so nice. I think I'm missing some stuff. So you do what? I think I deleted and consumed here. But that's actually fine because I'm getting rid of it. So bits, and then that's it, and then we return an error or usize, I think. No, an error or t, and that's it. And then this is a pointer to whatever. We return this. I think I left so many compiler mistakes here and there. I don't even know. So I need consume, yes. I don't need C anymore. I don't need this anymore. I don't need this anymore. I don't need consumed. I'll need consumed like a... Actually, just don't need it. Well, I think I need it here, right? Before I begin, I need to remember where I was. But that's it. So something like this. Consumed, consumed equals bits dot consumed. What did I use? Count. So this is like starting count. And basically we do while... Actually, we don't even need that. Look at this. So bit count is whatever we read plus bits dot count, and then we keep reading, we keep going until bits dot count is lower than bit count. Yeah, so this is more like bit end in practice, and we keep going until this is bit end. Do we need to increment anything? We don't even need to increment anything. Holy shit, why is this so much better? No shaming today. Hey, one line is left. Yeah, no shaming today. Actually, I started late. That's my excuse. No, but it's actually not going bad. It's like just tedious parsing work. But I don't know. It's fine. So I don't think I haven't compiled this in a while. I made so many changes. Let's start fixing problems. Unused local variable. Are you sure it's unused? Just because I forgot to pass it here. That's why it's unused. Okay, let's continue. Unused local constant p. Yes, you're right, because here we print p. Here we do the packet. And actually, we can go back to return this immediately. Unused undeclared identifier I. Yes, because this is bits.count. You got wrecked by a pointer. I was about to to get wrecked by the bit counting requirement that I didn't add in the beginning. And for some dumb reason, I wasn't thinking of just wrapping my... So basically I have a bit stream. I first read the hexadecimal stuff and convert it to bytes, and that gives me a slice of bytes. Then I put the bytes into a stream that reads from that slice of bytes, and then I put it into a bit reader. So the bit reader is like kind of like a reader interface that gives you where the unit is a bit. And so I use the bit reader to read a specific amount of bits from it, which is pretty nice for this type of stuff. Okay, so let's keep finding compile errors I haven't compiled in such a long time. Using the client identifier bit count. Yes, it's bit end now. Yes, so now bits is, it's my thingy, it's my bit reader. I specify the reader, and we can say that count starts at 0. Let's see, expected bunch of types. Okay, so this is my invocation that's causing a type error. Oh. Expected type pointer to bit reader. What's up with this? So this is the weird stream onion that we are making. But why is it okay? It's complaining because it's const. So this error needs, okay, this type of error needs to become, dude, this thing is const, should be const. That's fine. Why am I making this stuff const? Is this that makes it const? I'm not consting anything really, am I? Wait a second, why am I const? Oh, wait, what? P? What? So this is saying that I'm passing a... It's saying that the reader is constant. I think it's this. I think because this inline stuff is a problem. And I guess I need to put it explicitly on a variable for it to become a variable. I think your field needs to be a pointer. I don't think so. I think the problem is that I was basically inlining an expression in there. Actually, I'm not sure. No. Actually, I'm really not so sure anymore. I think I'm wrong. No, this is a different problem. So why is this stupid pointer constant? Self? Oh, what? Okay, never mind. I'm such a moron. Yes. So the giant error threw me off, but yes, the problem is this. This needs to be a pointer, otherwise I can't modify myself. Okay. No member name operator in a union. I call the control operator. Except the union type found slice of packets. Yes, okay, so we're going back to like normal errors. Let me see. Oh no, wait. Here. Expected error union type found packet. So I'm using try, but this doesn't have the exclamation mark to say that it can return errors, but it's trying a bunch of shit. So yes. Incompatible types. Oh, the try isn't binding close enough. Yes. Can't resolve inferred error set. Right, so I'm trying to put a inferred error set into a bunch of recursive stuff, which is a big problem. So here's my solution, any error. Error is ignored, consider using try. Right, when we append, we're allocating, so we could fail. Expected type packet, return found array list. Yes, I don't return the array list, I just return the items. I shouldn't, well, I shouldn't just return the items randomly. I should actually correctly detach the items from the array list. But it doesn't matter because I'm actually like not really doing a good job at managing memory nicely. Well, whatever, let's do it. It's I think it's 2 owned slice, right? Yes. So basically this takes the allocated memory, returns it to you as a slice, but then removes it from the array list. And so I guess at that point we don't need to free the array list anymore. But to be nice, like to be correct, we should call the init on it, but we are taking away whatever we allocated there. So array access of non-array type. Yes, I'm also, wait, what? That's a try. That's a try. So array access of non-array type, error packet, yes. Whoops. Okay, so we are back to compiling the basic example. What do we do next? Do we account for everything? Actually, yes. Okay, let's try to parse something more complicated then. An operator packet version 3 which contains 2 subpackets. Okay, let's go for it. Although I think it's not gonna, oh my god, it's not gonna be printed nicely. I guess I need to make my own cute printing stuff. What do you know? Reach unreachable code. So we read stuff that is different than 0, and I think that confirms that there was a misunderstanding. Okay, we don't do that anymore, fine. No. We are looping. Okay, the stream API is not great. You should actually complain when it's empty. So here's what's happening. We have a while loop here, and we never exit from it. So this actually ends. This is the one that never ends. Although it's kind of weird that parse packet never complains. Why is it not complaining? God damn it. Okay, you know what? It's easy. So here's what we do. Const result is this, and then if whatever is different than the number of bits that we requested, then we crash, and then we return result. Okay, so show me where it's doing stupid things. I mean, it's in the while loop, so there's no surprise there. But so the suck is, so we try to read the version of something, and that doesn't go well, as we are trying to parse it packet. We're trying to parse an operator. We're trying to parse a packet. We're trying to parse an operator. Packet. Okay, so we try to parse a packet, which turns out to be an operator, which contains an operator. And in there, we are parsing the operator body, and we reach the end. So don't forget to update the count. You're actually right. Not updated the count. God damn it. Yes. So we actually do need whatever. Oh god damn it. So it's actually a proper count. Oh wait. Okay, let's go with C. Count. Oh, self.count plus equals C. Okay, yeah, that explains it. What do you know? Now it works. Yeah, it doesn't print them nicely, but whatever. Seems to work. Okay. So let's see what people are saying. Okay. So this packet has version sum. So we need to sum the versions, right? Okay, let's do it. I guess let's do it. Function sum versions. P packet. Var result equals 0. Well, actually, result equals b dot version. Then we switch the version, the union part. And wow, I didn't know I had this snippet in, in Sublime. Okay, so we switch p dot extra. And if it's a literal, actually it's dot literal. So if it's a literal, we do L dot version, or we do result plus L dot version. Otherwise, if it's dot operator, it's an operator. Oh. Then for each, well, we need to. Okay, let's put this stuff in a block correctly. Also, it's result plus equals. So if it's an operator, we need to do. Wait, what am I doing? This is my own packet. There's no version in there. If it's a literal, we good actually. We don't do anything. If it's an operator, if it's an operator, so if it's a literal, just empty brackets. We don't do anything. If it's an operator, then for operator dot I think it's directly a slice, right? The constant of operator, yeah, it's a slice directly. So for each packet in there, sub packet, I guess, we do result plus equals some versions of SP, and then we return result. I guess. Also, it's maybe nicer if we actually do call the function. So except type U3 found use size. Oh, right. No. Result 12. 12. Okay, let's do this. 23. Oh my god, copying on Mac. Command. Yes, command. Command. 23, yay, 31. I think that if this one works, we're good. 31, yay, okay, puzzle input. Right, giant number. $947, let's see. Yay, part 2. Now that you have the structure of your transmission decoded, you can calculate the value of the expression it represents. Literal values, type ID 4, represents the number described above. The remaining type IDs are more interesting. Sum, product, minimum, maximum, greater than, less than, are with 1 and 0, okay, and equal to. Using these rules, you can now work out. Okay, let's go do it. So, what do you know? Having these two tags isn't that bad, because this allows me to, it's kind of wasteful, but I can use the type ID to, like, I don't need to create all the extra union types. I keep it like this. And then some versions, we do another thing, call it some, I don't know, apply, I guess. Any recursives over apply. Okay, so packets with ID type 0 are sub-packets. Their value is the sum of the value of their sub-packets. If they only have a single sub-packet, their value is the value of the sub-packet. Okay, so let's do ID 0. So if it's an operator, okay, now we do something more complicated. So if it's an operator, then switch over p dot type ID. So 0, we said it's a sum. So actually I could make like a functional version of this stuff. Maybe it would be easier, but whatever. I mean, yeah. There's no point to do it differently, is there? Like equal to, if the value of the first subpacket is equal to the value of the second subpacket, otherwise the value is 0, these packets all have exactly 2 subpackets. Well, good to know, but do I even care? I think I'm making like a bunch of implementations that have the common signatures, and then I apply them functional style, like a boss. And I think it's something I can reuse from the standard library even. Yeah. Fuck it. So how do we do it? So like function sum takes in a slice of packets. And I think sum is, okay, wait. It depends how complicatedly nested is this stuff. Their value is the sum of the values of their subpackets. If they only have a single subpacket, the value is the value of the subpacket. So we're not looking at versions anymore, right? We're just looking at the... But there could be a sum of a product. So we still need to go through the apply. Oh my god, is this a Lisp? Is this all this work just to make a janky Lisp interpreter? Is that all? Is always programming like this? J-Dog, thank you for the follow. Okay, I think we need to change this slightly, right? Apply needs to be different. Okay, it's Lisp time. Lisp time. Apply has a different signature. It's like apply, let's say it's an operation on a tail, which is a slice of packets. Okay. So it's an operation on a tail of packets. So applying an operation on tail of packets means doing what? Means doing what? Means switching on the operation. So the operation is gonna be a U3, I guess. Let's keep it a U3. So we switch P. Wait, why is it P? It should be OP. It should be head. Oh, do we keep it at... we can also keep it as a packet, actually. You know what? Let's keep it as a packet. Head, tail. So we switch the head, and the head has to be... I think we should kind of assert that it's an operator. We can do head.operator. Although, oh, we can do it like this. Oh yeah, you know what? We can do this. If it's a literal, actually, yeah, let's do it like this. If it's a literal, we immediately return. We immediately return L. If it's an operator, we switch to the type ID. But we do, okay. Head.extra. And if it's an operator, so this is the sum. Then we return for, okay, so basically var. Oh, there's always an accumulator, goddammit, and a function that we apply it to. Oh my god. I just need to wire in correctly, apply in my function. So let's say that I do have a sum function. So it returns a usize. How should this sum work? We have... because we need to first apply... Oh my god, my brain is melting. You know, I actually had an exam that was about implementing a actual Lisp interpreter. It was 8 years ago, 10 years ago maybe. So I don't remember anything. But it wasn't that hard, I remember. Okay, let's stop being clever. Trying to be clever. Let's just do the work. So it's 0, so it's a sum. So we have bar result equals 0, I guess. Oh, you know what? Result equals 0, we have it every single time. Yeah, and it's not the version. It starts at 0 every single time, I guess. And then for each I don't see why apply. Yeah, no, you're right, it doesn't. So for each yeah, let's go back to P. So for each element inside O, sub packet, we do result plus equals apply on SP. Well, or like it's not really apply, it's more like eval, right? Evaluate. So we evaluate SP, and if SP is a literal, we just it evaluates to itself. And actually you could say that basically this means result equals L, I guess. Just we return result. We keep adding on it. And that's one case. And if it's a 1, we do something different. Do we need these brackets here at this point? Okay, let's see what's the parsing error. Expected semicolon 126. Why would you expect a semicolon? Oh, here, yes. And then expected statement found comma. It's this. Okay. So could I just do this then? Because I think it's the same, right? So our product packets, their value is the result of multiplying together the values of their subpackets. So this is just star equal. Minimum packet. This is a bit more complicated. The natural element of mul is 1, not 0. Fuck, that's a good point. So how do we do this? I guess we set it before the 1. Yeah. Then we said 2 and 3 are min and max. So for min and max, how do we do min and max? That's also a bit more complicated. So for min and max, I guess we do result equals the first element in O. And then for O 1 to the end, we do right, max and min work on the entire slice. We can do this straight up, std.man.min, I guess, right, over O. Oops. So that can, okay, that can actually be simplified. Same with 3. Let's go. Greater than, less than. Okay. But those are packets, not numbers. That's a good point. Fuck. So that doesn't work like this. So okay, let's set the first 0 dot. The first result is evaluate the first element, and then for each other remaining element, right, until o.len. Can't forget about this. So for what we do is std.math. I think it's math.min, right? That accepts 2 values. It's between result and evaluating that element, and whatever it is, we put it in result. So I think this is correct. We evaluate the first element, we put it in result, and then we find the mean between evaluating. Yes. Skipping 0. Actually, we don't need it, like we could, whatever. Mean in itself, it's still gonna be the same. So 3 is gonna be the same with max. Then 4 greater than. So 4, I guess kind of the same thing, except we don't have a. I don't even know why I care so much about like the standard library function. It doesn't matter, right? It's like result is, well, no, it helps me do the assignment, I guess. 3, oh, you're right, that's 5, 4, we already have, so 5. We can say it like this: 4 unreachable. 5 is greater than. So we start with the first element, and for each element, if well, for each element we need to assign stuff. Const x is eval plus p, and if x is greater than, was it greater than? Yes. If x is greater than result, isn't it the same thing at this point, min and max, now that I think about it? Yeah. Well, so here's then what I can do. Greater than is basically this, right? I think I can do this. Oh, it returns bool, right. So this one, min and max returns the value. This one returns 1 and 0. Yes. Good point. So I guess result is if evaluate 0 is greater than evaluate 1, and result is 1. Or you know what? You can leave result to 0 and say, you know what? If this happens, then result plus equals 1. Otherwise, we just don't do anything. And I think we can simplify this. Double comma. And 6 is gonna be the inverse. So plus equals, yeah, you're right. It's like, yeah, it's true. It's an assignment. Okay. If it's less than, if the value is 1, if the value of the first subpacket is less than the value of the second subpacket. Okay, almost there. 7 equal. Holy shit. So 7 is 1 if they are equal. I think we have covered the entire switch. We don't need an else branch. Invalid left-hand sign to assignment 0. Oh no, why do you say this? It's not really an assignment. What are you talking about? I guess it needs this. Yeah, I guess for this stuff I need to. Why though? So annoying. Okay. Oh, semicolon. There we go. $947. Yes. Because I'm calling some versions. And I'm calling evaluate. Wow, big number. Wait. So is this it? What do you get if you evaluate the expression represented by your hexadecimal code this transmission? Oh, wait. So this is it. Okay. Oh, this is giving the other thingies. These numbers are so low. Why is mine so giant? Never mind, it's the right answer. Okay, we did it. Man, that was a lot of work. Switching between two different OSs. Yes, I have a virtual machine with Linux, with Nix OS, and the host machine is a Mac machine. So we have it. This wasn't too bad. This type of stuff is, I don't know, I guess could be worse. What I was half thinking of doing, which I failed to pull off because it requires too much brain power, was basically to transform all of these in apply the same operation. Like instead of having a switch, I just call like apply, comma, SP, and I apply on type ID and SP basically, and then I have a functional way of basically just mapping these operations in a nice way, and if you can have all of them have the same signature, kind of like this. Well, I mean, I think you get the idea. Cool. That's it. Holy shit. So, yeah. Done with day 16. Day 16. Easy, but lot of work. That's it. I use an enum for the OP type. Yeah, I kind of wanted to do something cute. Like the idea was basically you can do something like this. You can make an array of functions. So like you can make a slice const funcs is like an array of functions that take a U3. Well, no, not even a U3, because the function itself, you know what the aggregator is. It's the function itself. So it only takes a slice of packets, I guess, and returns a usize. And inside this function, so inside this array, basically like first element, I don't think so in Ziggy I don't think you can define them in line, so you have to define them outside. But then you have function sum that takes in a slice of packet and returns a usize. And what you do is, well, basically kinda most of that, right? You would still have to write most of these, unfortunately, I think. Yeah, so I was trying of kind of simplifying this, but I don't think you can escape from basically having most of this stuff somewhere, and at this point having it all in here or somewhere else doesn't matter. Never mind, we don't have the tools to do anything more clever than that in Z. That's cool. Well, thank you everyone for watching, and see you tomorrow. Holy shit, these out of code exercises are requiring a lot of effort. We did a reduce function too. Yes, that was the more or less the general idea. This one was tough for me, but two-step, wait, sorry, just to make sure I understand what you're saying. It was fun to do it casually. You're referring to me doing it casually, right? You did it in a rush because you were trying to compete. Is that correct? Or you also did it casually? Well, kinda like me. I did it more casually, I see. I see. Yeah, I think that your suggestions were amazing. Like without the bit stream, like the bit reader is pretty cool. That's exactly what we need. And yeah, also I should have thought about immediately about wrapping the reader. I don't know. The thing I was doing was sometimes I'm fine with doing like something that is not super neat just for the sake of it. But in this case, the thing that I was going for was a disaster compared to this. This is so good. We made our own counting reader, basically. And it's so not error prone. So nice. Well, thank you again. Thank you to Step. Thank you everybody else. Let's see who we can raid. Who can we raid? Guess what? As usual, nobody really follow is streaming right now. Why? 2021 year in review inside Unreal. Oh, they're gonna try to sell you NFTs, so maybe not. React Next.js. Putting F in OCaml. What? C coding? C coding it is. Hey, Specs. Sorry, you are... well, I don't know. Oh, you're just saying goodbye. Okay, sorry. I thought you, like, went away and came back. Sorry. Oh, it wasn't a hello. Then you missed out on a beautiful solution. Well, no, I think you saw the beginning, so everything else, the rest is kind of what you would expect. Bye bye.